So today we're going to review over scatter plots. So some refreshers. To create an equation of best fit, you want to make sure that when you're drawing a line of best fit, that you have equal points above and below the line. So you'll have a bunch of dots, and it's going to form some kind of trend. And you want to make sure that whenever you draw your line, that you have an equal amount as above and below as much as you can. However, you don't want it to be uneven. So like if I drew a line like that, yeah, I may have half above and half below, but it's I have more above, below, or at the bottom of the line than I do on the top of the line. So you want to draw it so it goes right through them instead. Also, if there aren't any outliers, you want to leave them out. So if there is a point that's way up here, then you can just ignore that when you're drawing your line. You don't have to accommodate it by making it go through the line. You find the slope just like you would find the slope of a normal line, rise over run, in the y-intercept, and then you fill into y equals mx plus b. So a lot of times finding the scatter plot by hand is going to be faster than the calculator. So you either learned from me or Mr. Bunovich that you would put the table into your calculator, and then you would do all of this calculator work to find the equation. And while that is a very trusty method, it is not the fastest method. So you're going to want to use it, do by hand instead, because it's going to go a lot quicker. If given equation answers, you can also save time by graphing each option and seeing which looks the most like the scatter plot. And when you do that, you'd want to change the window to match the scatter plot. So if the scatter plot has the x-axis going from 0 to 50, you would change the window to have it go from 0 to 50. And I'll show you how to do that in one of the problems. A lot of questions sometimes will talk about correlation. So positive correlation and negative correlation. That is just a graph is going up is positive versus down if it's negative correlation. So if something has a positive correlation, that means that both values, so both of the things on the axis, the x-axis and the y-axis, would go up. But if something has a negative correlation, it means this one thing is going up, the other thing is going down. A weak versus strong correlation. If something has a weak correlation, the data doesn't follow closely to the line. And if it has a strong correlation, it follows closely to the equation or the line of best fit. However, a scatter plot is not going to be exact. It's not going to be perfect. Every point's not going to be exactly on it, or else it wouldn't be a scatter plot. And the last correlation we're going to talk about is linear versus quadratic versus exponential. So a linear is going to follow a line-like pattern. It's going to have y equals mx plus b. That's going to be the equation of that. Versus the quadratic, which is going to be a U-like shape. It could be upside down as well. And that has the equation y equals ax squared plus bx plus c. So basically it'll have a squared. And the last one's exponential. That's a half a u. And that follows the equation y equals a number times another number raised to the exponent of x. All right, so let's give one a try. So it gives us a scatter plot over here, and it says the wind chill reflects the temperature that one feels when outside based on the actual temperature and the wind speed. So that is just naming the axis right here, the wind speed and the wind chill factor. If you notice, it has two separate dots. It has the round ones and the square ones. So we have actually two separate scatter plots on this. says if the outside temperature is 0 degrees, what is the approximate wind chill at 40 miles per hour based on the 2001 formula? And what wind speed would produce the same wind chill using the 1939 formula? So it's asking two questions, and so two separate answers. So I'm going to figure out the first one. So it says at 40 miles per hour based on the 2001 formula. So the first thing I want to do is draw my lines and curves of best fit. And so they kind of look like curves, so I'm just going to kind of draw a line that goes through most of them. So that's that one. And do the same thing for this one. So somewhere through. Doesn't have to be perfect. Okay, so 40 miles per hour based on the 2001. So looking at the squares, so the red line, I want to find the 40 miles per hour. So that would be right here. So I'm going to have to extend that red. So I'm just going to continue that trend. And so at 40, when I go up, that is right in between the -20 and the -40, so that would be -30. So A and D are out, because both of A and B have -30. So then I need to answer the second question. So it says, at what wind speed would produce the same wind chill? So that basically means this wind chill was -30 for that, so I need to look at the green now at -30. So -30, the green is right here. When I draw that down to figure out the wind speed, because that's what the question's asking, wind speed, that looks to be closer to 15 than 10. So my answer would be B. So just to review the first step, you want to create the line or curve of best fit if you can. And then you have to make sure that you're looking at the units. So I looked at what the question was asking me. It was asking me about wind chill, and it was giving me the wind speed. And so I was able to look at my axis and figure out which one I need to be looking at. The second one, the graph to the right shows the percent of school-age children in the U.S. who received immunizations for various illnesses. What was the average rate of increase in the percent of children? So when it says rate, that's talking about slope. Whenever you hear the word rate and it's talking about some kind of line, that means slope. So in this case, I am already given the line. I don't have to create it myself. So I just need to pick 2 points on that line. So I'm going to pick this one. And then I'm going to pick another nice one. That's a nice one. So then remember, slope is rise over run. So I draw my triangle. So the rise, I'm going from 20 to 30, so that's 10, up 10. And the run right here, 1998 to 2000, is 2. And that simplifies to 5. So my answer is A. So you do it just like we did when we did slope of regular lines. Our last one, in 1983, the British Parliament enacted a mandatory seatbelt law. The scatter plot shows data collected each year after the law was enacted. Which of the following equations best represents the trend of data shown in the figure? So there's 2 methods, depending which one you find quicker. So the first one is to actually figure out the equation the best that you can. So the first thing you want to do is find the y-intercept. And so what I would do is draw your best line of best fit. So what I do is I usually circle all of them, and then I draw a line that goes through it. So it'd be something like this. Okay. So then when I'm looking at the y-intercept of these things, that's right here. The 25, the 15, and the 35. So 35, that'd be right here, and that's too high. So C, I'm going to eliminate. Then B, 15. 15 seems a little low. That's right here, so I'm going to eliminate that. So now I'm down to 25. So my y-intercept is 25. My second step would be to find the slope. So I don't have to find the exact slope. I can just compare the slopes that they gave me. So the slope of the first one is 0.4, and so if I would convert that to a fraction, that would be 2 over 5. So my rise would be 2, my run would be 5. The slope of D is 2.6, and if I converted that to a fraction, I would get 13 over 5. And so the rise is 13, the run is 5. So these slopes are rather different because the slope of A has a smaller rise than it does a run, and the slope of D has a larger rise than it does run. So I should be able to figure out if this graph has a larger rise or a larger run. So I am just going to take 2 points, so we'll say right there and right here. I have to keep in mind the scale of the axis. So if you notice, the y-axis has a larger scale. So really that rise, while it may look a little smaller, really from 20 to 40, it's 20. And the run here from 0 and the other point is 6 is 6. So it doesn't really matter what the rise and the run is in this situation. I have a larger rise than I do a run. So that means that D is my answer. So the second method that you could do for this one is you could just graph each option and see which one looks the most like it. So you do need to remember to change the window first. So I look at my axis, and the x-axis is going from 0 to 26, and each of those ticky marks is 1. The y-axis is going from 0 to 100, but each of those ticky marks is going by 5. So I have to keep that in mind. And so after I change my window, which I'll show you how to do that, you would graph. So then I grab my calculator. So you hit window. So right now the x minimum is -10 and it's going to 10. So I'm going to change it from 0 to 26, and the scale is 1, so I'm good with that. My y min is going from 0 to 100, and it's skipping by 5s, so I change my scale to 5. So now it's going to have the same window as my graph. So then I go and I graph each of them. So this one doesn't look like it, so A is out. Didn't have a steep enough slope. That one, if you look at the far right-hand side, it doesn't go up far enough, so that's out. That one on the far left starts too far up, so that's out. And so clearly we know it is D. And I will just show you that. So that is the best choice. So while this is maybe not the most accurate, you are taking a little bit of a chance. If you're running low on time, it's definitely the way to go, unless you happen to have extra time.